Okay, so we're going to cover section 4.1. This section is about ratios, and I've typed up a definition of what ratios are, and it is ratios are used to compare amounts or quantities or used to describe a relationship between two amounts. So I'm going to write the three different ways that we are able to write a ratio. I'm going to write them on this screen, so ignore that little piece there. The first one is in what looks to be fraction form, but you're going to use a bar, okay, bar form. You can also, as that says or, you could also write the word to compare, or the last way is you can write a little colon to compare these. So the way that you read this is 1 to 2. So it's actually the TO is what you read when you compare each of these, and you see that symbol in the middle. You're going to read it, the top number 1, you're going to say the word 2, TO, and read the bottom number 2, which is TWO. So you're going to read it, any ratio like that. So I want to point out that we said that there are two amounts. So if you ever end up with a ratio that is stacked what we call fraction form, it will never simplify and become a whole number. The reason it will not is because we are actually comparing two amounts. It is not actually looked at in the same way that a regular fraction is. So you will always have something in fraction form, even if 1 is on the bottom. All right, let's try a couple of examples here. So our first one is going to be 86 cans of pop to 20 people. It's possible that these will not be written in ratio form when they're first given to you. It'll kind of be a couple of sentences where you're supposed to set them up. So we'll look at one of those in just a second. But we have 86 cans of pop on top and 20 people. So if cans of pop was on top and cans of pop was on bottom, we could cancel the units, which is cans of pop, if they both matched on top and bottom. But here they don't. Cans of pop and people are two totally different things that we're comparing. So the only thing that I can do with this problem is I can look at the numbers, and I can see if both of these numbers have a number in common that I can divide them by. So I'm looking to simplify. So I know that they are both even numbers, so I'm going to start by dividing both of them by 2. When you simplify, you choose to divide both the top and bottom number by the same exact number. So 86 divided by 2 gives me 43, and 20 divided by 2 gives me 10. And remember that the labels stay with it because I didn't cancel out. So what I actually have here, let's say that we're hosting a party or a get-together or something. So I have 43 cans of pop for every 10 people. And that sounds like plenty of pop for every 10 people, because that's a little bit over 4 for each person. So I think that that's plenty depending on how long the get-together is. So ratios can help us compare things and describe a relationship between two items being compared. So I told you that they won't always be written in the ratio form, but they'll be given to us. So that says 40 minutes compared to 70 minutes. So we read from left to right. We also read from top to bottom. So when we read from left to right, whatever we came to first goes on top. Whatever we get to second goes on the bottom. Okay, so here I see I have minutes, and the units are the same, so they cancel. The other thing that I have is I have 40 and 70. Okay, remember I am not trying to make this a division problem to turn it into a mixed number because it is not a fraction. It's comparing two items. So I'm not going to ever change it, even if the top number is bigger. We are not doing that in this unit. So I am looking to simplify this, but I can divide both of them by 10, and I end up with 4 to 7. Notice I did not read this as 4/7 because it is not a fraction. It is 4 to 7. We're comparing two things. So 4 to 7 is my final answer. All right, so on this one, it looks like we are talking money. And I'll tell you that you have one of these that shows up in your My Open Math homework. And it will tell you to write a ratio of whole numbers. And I do want you to notice that these are actually decimals, so these are not whole numbers. So how would I be able to make these whole numbers? Well, the decimal would have to be on the other side of the 20, right? On the right side of the 0 for that 20 to be a whole number of 20, not 20 cents. So I need to move the decimal 2 places to the right for both of these. And so then I end up with 20 to 50. Whole numbers, right? They're both whole numbers now. I move the decimal the same number of places on the right one as I did on the left. I moved them the same number of places. And so now I'm going to have to simplify by dividing both of them by 10. And I find 2 to 5, not 2/5, 2 to 5. We're comparing. And so this is my final answer for this problem. All right, the next thing that we need to talk about is something called a unit rate. So I'm going to type up unit rate. A unit rate compares a quantity to 1 unit of measure. All right, so unit rate is something, the unit rate wording is something that should tell you this is how you should look at them and how you should solve these problems. So for example, the problem that I'm going to give you to work first is this guy. It says we drove 121 miles and used 11 gallons of gas. It wants to know what our unit rate is. Okay, the unit rate, that's what we're looking for. So unit rate compares a quantity to 1. So a quantity on top to 1 is what we're looking for. We're looking for a 1 on the bottom. Well, we can't quite do that yet until we set up our problem and simplify. So here's what we're looking for. We're going to read from left to right, and we find 121 miles to 11 gallons of gas. Okay. And so again, remember we're looking for a unit rate to be on the bottom. So we're looking for 1. 1 gallon of gas is what we're looking for. Why do I know that it's going to be gallon of gas? Because the miles and miles on top and the gallons of gas on the bottom are not going to cancel. So we still have to have the units. So if I go back to this and I look at what I have, what do I have to divide by to get my denominator or my bottom? I shouldn't call it denominator because it's not a fraction, but the bottom unit, how do I get the 11 to become a 1? Well, whatever number I see on the bottom is what I have to divide by, because 11, if I divide it by 11, I get 1, and that's what I have over here. That's what I have to have. So if I divide the bottom by 11, I also have to divide the top by 11. Now, sometimes when you have unit rate, it's possible that that division problem that you do on the top is not going to give you a whole number, and it's okay. But for this one, when we do this division problem, when we type in our calculator 121 divided by 11, we end up with a final answer of 11 miles. So what did we find? We found a unit rate because the bottom ratio or bottom measurement is 1 unit. And this should be familiar because the way that I read this final answer is actually 11 miles per gallon. Right? Miles per gallon, that is a ratio. We talk about that a lot when you're driving, when you're checking your miles per gallon for your the gas that you put in your car. So a unit rate is something that you are familiar with. So this could be a final answer, or this right here could be a final answer at the bottom. All right, your next one is going to be your pulse. You take your pulse for 3 minutes. What is the rate if he counts? All right, so here's the problem. It says you take your pulse for 3 minutes. What is the rate if he counts 249 beats. So I'm going to point out two things. Here's my first thing being compared, here's the second thing, and here's how we know how we're going to solve this problem. Rate is unit rate. So we're looking for a bottom measurement to be 1 unit. Okay? But I take what I have and I write my ratio from that. So I have 3 minutes and I have 249 beats. So let's think about this. Is minutes per beats, does that sound like we want to write it in that ratio? Why did I say minutes first? Because we read from top to bottom. So I would have 1 minute per so many beats. It's never going to work out that way, right? We want the bottom to be a unit of 1. So if I actually switch this to the bottom and this one to the top, I could end up with so many beats per minute. And that actually sounds like something we want. So we want to make sure that we are setting up our unit rates in the correct order. So 249 beats in 3 minutes. But I want my per minute, 1 minute, to be on the bottom. So if I take 3, how do I get 3 to become a 1? I have to divide it by 3. I divide by whatever I see that I want to go away, right? So then this becomes 1 minute, and 249 divided by 3 is going to give me 83 beats. So I have 83 beats per minute. Final answer. The 83 to 1, that setup with the fraction bar, you would need to make sure that you had your units in there. So if you put 83 beats 2, which is that bar, and then on the bottom you had 1 minute, you would need to make sure that you had your units written in that fraction setup, okay? All right, the last thing that we need to make sure that we do or talk about is pricing or comparing of prices of things that you're buying at the store. So for example, we're going to say that we're going to the store and we're purchasing some peanut butter, because it seems like at Sam's you can buy peanut butter in crazy, ridiculous, huge quantities. So we're going to say that brand A of peanut butter, you can buy it for $2.35 for 50 ounces. I realize that's probably not accurate. But the second one is brand B, and brand B costs $4.15 for 72 ounces of peanut butter. So what I'm trying to see is which one is the better unit rate? Which one's the better deal? For those of you that don't want to spend money, the $2.35 sounds better. But it's possible that if you spend $4.15 to get 72 ounces, it's possible that you're spending less per ounce by buying it in bulk in a bigger size. So we're going to see if this actually works out to be true. So the way that we find a unit rate for money per ounce is ounce will always be on the bottom. So I want you to see money goes first over your ounces. On the bottom one, you take your money first and you divide it by your ounces on the bottom. So we're looking for a unit rate. So that means that the bottom needs to be 1 ounce is what we're going to. Well, on the top one, how did I get 50 to become 1? Well, I divided it by exactly what I want to go away, the 50. So if I divide the top by 50, when I type in 2.35 in my calculator and I push the divide sign and I type in 50, 50, push equals, I end up with brand A to look like this, 0.047 per ounce. So what is the 0.047? It's money, remember? So we're still talking about money. So this is actually about, if you rounded it, because we don't have 3 decimal places in money, this is actually about 5 cents per ounce is what we're looking at. So on the bottom, to get the 72 to become a 1, I divide the bottom by 72 and the top by 72. So I type in 4.15, push divide by 72 equals, and I find brand B to be 0.058 cents per ounce. So this actually is about 6 cents, and this one's about 5 cents. So which one is actually the better deal? Well, the one that's cheaper. So actually brand A is the answer, because it's 5 cents per ounce, and that's cheaper than almost 6 cents per ounce for the bottom one. All right, so that wraps up our first section, which is section 4.1. Make sure that you do your try on your own problems and text me if you have any questions.